Hello, and congratulations on completing APP 101. Today we will begin our second portion of Anatomy, Physiology, and Pathology. In our first section we covered the cells and tissues, the basics of pathology. We also covered the integumentary system, the skeletal system, the muscle system, and the nervous system. Today we will pick up with the cardiovascular system. We're working from Introduction to Massage Therapy, Chapters 3 and Chapter 5 still. We begin today with the cardiovascular system. The cardiovascular system is a circulatory system. It provides a link between the external environment and the internal fluid environment. It carries nutrients and gases to all the cells, the tissues, the organs, and the organ systems, and removes metabolic waste. The exchange in the body is necessary to maintain the homeostasis, or that internal balance system we have. Massage helps to promote this by mechanically moving the fluids, and thereby exchanges the delivery of the vital ingredients and assists in removing the waste. So the primary structures of the cardiovascular system include the blood, the heart, the blood vessels, and the blood circuits. With the breaking each of these down briefly, in the blood we have the components of the blood: the plasma, the erythrocytes, which is red blood cells, leukocytes, or white blood cells, and the platelets, those are your clotting cells. A single drop of blood contains about 10 million separate blood cells. Blood is a liquid connective tissue. We talked about that a little bit before, about how we classify the blood as connective tissue because it connects different parts of the body together. In your blood plasma, it's talking about plasma being a clear straw-colored matrix. It's similar in composition to cytosol, so the liquid inside the cell. It's mostly water and contains proteins, glucose, salts, vitamins, hormones, antibodies, and waste. It acts as the transport system for delivering gases and nutrients throughout the body. Erythrocytes, these are also called red blood cells, or RBCs. They are biconcave, rounded structures with a central depression. If you see on page 119 there on the bottom, it shows you the picture of the erythrocytes. The erythrocytes are the only cells that do not have a nucleus. Instead, they are full of hemoglobin molecules that transport oxygen and buffer the pH of the blood. A tiny drop of blood contains over 5 million red blood cells that circulate throughout the body 300,000 times in about 4 months before they break down and are actively destroyed by the macrophages. So in one drop of blood you have 10 million separate cells. Of those 10 million separate cells, 5 million of them are red blood cells, or erythrocytes. Okay, so next we talk about white blood cells, or leukocytes. These are clear, colorless, or have a clear, colorless appearance. They differ from erythrocytes because they're larger, they have a nucleus, they do not carry hemoglobin, and they have a special ability to squeeze through the cells in the capillary membranes to reside in the interstitial fluid. Sorry, my phone dinged. I'll turn that off for us real quick. Okay, there's 5 different types of leukocytes: neutrophils, basophils. I never get this one right. Eosinophil. So that's not it. I can't say that one. Eosinophils. I still don't think that's right, but you get the picture. Page 120. Lymphocytes and monocytes. They all function to defend the body against disease and foreign substances by destroying pathogens, which are basically bacteria, viruses, fungus, any kind of carcinogen, a harmful substance to the body. 1 drop of blood contains about 5,000 leukocytes, in contrast to the 5 million erythrocytes. So the leukocytes are produced by the bone marrow, and they circulate within the tissue for less than a day or reside in the tissues for months or years, depending on the severity of the infection or injury. We have platelets. Platelets are also called thrombocytes. They're small, irregular, non-nucleated fragments of cells. They're formed in the bone marrow as extensions of megakaryocytes that break off. These components are half the size of a red blood cell, and usually there's anywhere between 150,000 to 400,000 platelets in a drop of blood. Their main function is blood clotting, also known as hemostasis. Now we have homeostasis or homeostasis. That's the balance of the body, the internal balancing system. And then hemostasis is the actual process of clotting blood. They can respond within 15 seconds to 2 minutes of the injury. So whenever you get a cut, within 15 seconds, typically the thrombocytes or the platelets are actively engaging that site to begin to stop the blood loss or to work on the hemostasis. Okay, next up we have the heart. Of course, the heart's the main structure of the cardiovascular system. It's about the size of a fist. It's located between the lungs in the middle of the thoracic cavity. It has 4 separate chambers. These are separated by muscle walls and valves. The upper 2 chambers are called the atria, and they are encased by thin walls of cardiac muscle. The left and right atria are receiving chambers for incoming blood. And then you have the 2 ventricles on the lower half. They sit just below the atria. The ventricles are the discharging chambers responsible for pumping the blood from the heart to deliver it to the rest of the body. Continuing on in that section under the heart on 120, the myocardium, or cardiac muscle tissue, can vary in thickness. It's arranged in spiral bundles that wrap around heart chambers. The spiral bundles contract with a ringing action that squeezes out the blood of the chambers. Cardiac muscle tissue contracts spontaneously and independently, unlike skeletal muscle, and contract even if all nerve connections are severed. Cardiac muscle fibers contain electrical impulses that exchange charges back and forth to create rhythmic contractions. These rhythmic contractions allow the heart to push approximately 6,000 quarts of blood throughout the body each day. And we have in the heart, we also have the valves. They're one-way gates. They allow blood to flow only in one direction if everything's working properly. We have the atrioventricular valves, or the AV valves. They sit between the atrium and the ventricles and are forced to shut when the ventricles contract to prevent the blood from leaking into the atria. Then you have the semilunar valves. They're located at the exits of the ventricles. When the ventricle contracts, the semilunar valves are forced open and allow blood to only flow out of the heart. It doesn't allow it to come back into the heart, assuming the valves are working properly. Okay, blood pathway within the heart. We'll talk about it here in this section. Actually, let me double check and make sure. Your arteries, your veins. Okay, just wanted to make sure I didn't have a detailed point on the blood flow. I didn't think this video or this PowerPoint had that, but I wanted to double check anyway before I continued on. Okay, so if we look at the heart on page 121, right below it, it gives us a diagram, 6 steps that the blood follows as it works its way through the heart. So if we look back up at our heart, we see a red, the red arteries and the blue veins. The blue represents unoxygenated blood. The red represents the oxygenated blood. And be sure you study this. You will possibly have to diagram the picture of the heart. And you will have to know the flow of blood through the heart. So make sure it's very important you learn page 121. Okay, so we start out. Oxygen depleted blood collects in the right atrium. The right atrium contracts, pushes the blood through the AV valve, the atrioventricle valve, into the right ventricle. The ventricle, full of oxygen-depleted blood, contracts to push the blood through the semilunar valve into the pulmonary artery and out to the lungs. The blood receives additional oxygen in the lungs and goes out through the pulmonary veins into the left atrium. From the left atrium, it contracts and forces the oxygen-rich blood through the AV valve into the left ventricle, and then the left ventricle contracts and forces the oxygen-rich blood through the semilunar valve into the aorta, where it enters the atrial system and is delivered to the body. Sounds very brief, very simple, but make sure you know that. Into the right atrium, down through the AV valve, into the right ventricle, out the ventricle then contracts and pushes the blood out the semilunar valve to the pulmonary artery, to the lungs, then receives oxygen, comes from the lungs back into the left atrium, then goes, as the left atrium contracts, forces the blood through the AV valve into the left ventricle, and then as the left ventricle contracts, it forces the oxygen-rich blood through the semilunar valve out into the aorta. And something that really kind of always amazed me is the aortic arch is the size of a garden hose. So like you think about all these arteries and veins being so small and stuff, or I always did, but the aortic arch is actually the size of a garden hose. So that's a pretty good size hose there for our blood to be going out from the heart into the rest of the body. Although there is a specific path, left and right atria contract at the same time, and the left and right ventricles also contract at the same time. But it's flowing the path that we mentioned above. Okay, so we'll move on. Blood vessels. Blood vessels transport blood from the heart to the rest of the body and then back to the heart. Of course, we have arteries, veins, and capillaries. Typically, that is or collectively, that is the blood vessels. The largest blood vessel is the aorta. Measures about 1 inch across, where it leaves the heart to transport the oxygen blood to the entire body. And then the smallest of the blood vessels are the capillaries. These are less than 1/10 of a millimeter in diameter. Their small size limits the passage of molecules to a single file. Your arteries go specifically into each of those. The artery is a tube that carries blood away from the heart. Your vein is the structure that transports blood from the capillaries back to the heart. So your artery carries blood away from the heart. Your veins carry blood to the heart. And then your capillaries, those are the really fine vessels that are actually where the gas and fluid exchange occurs. Okay, blood circuits. There's 2 different blood circuits. There is the pulmonary and the systemic. The pulmonary circuit on page 122 now is what carries deoxygenated blood from the right ventricle to the lungs, where it then becomes oxygenated and the gas exchange occurs. Then the pulmonary vein carries the oxygenated blood back to the heart. So the pulmonary circuit is just basically coming out of the heart, going to the lungs, and then coming back from the lungs back into the heart. The systemic circuit is pretty much everything else. It's where the arteries carry the oxygenated blood out to the body, and then the gas exchange occurs at the capillaries, and then the deoxygenated blood is carried back to the heart through the veins. So this is a picture of your arteries represented in red, and then we have the veins in blue, and almost all text are going to represent it the same colors. Red is arteries, blue is veins. Okay, so we've got several videos for you to go watch, so we're going to pause, let you go watch those, and then have you come back. Okay, so I hope you enjoyed those videos. Some of those, they go a little fast, so you may have to go back and re-watch it a couple of times to be able to really comprehend everything, because it's so much information so quickly. But I chose these videos specifically because they are freely found on YouTube, and they're very informational, and they tend to move at a faster pace, so it kind of tends to keep you awake a little bit. You kind of have to keep stay awake and pay attention to get all the information. And plus, with my ADD-ness, I need something really catchy and upbeat and moving quickly to kind of keep me interested. So hopefully it doesn't mess too many of you up that aren't ADD. If you have suggestions or comments about the videos or anything, you can feel free to let me know. And if we need to change it, or if I need to find different videos just for you, we can do that also. Okay, so 123, we're talking about the functions of the cardiovascular system now. Of course, the primary function is transportation. It's going to basically transport blood and all of its components. It carries the oxygen, the CO2, the hormones, and the nutrients. It also functions, in addition, as protection. It carries important substances that fight pathogens, specifically, remember those leukocytes. And regulations. It controls the size of the blood vessels. So for transportation, we said it carries the oxygen, the carbon dioxide, hormones, nutrients. It uses the blood as a transport mechanism. The cardiovascular system then carries the different substances to and from all parts of the body. There's a certain pathway for taking blood from the heart to the lungs to pick up the oxygen. We talked about that with the pulmonary circuit. And a separate path delivers oxygen-rich bloods from the heart to the cells of the body with the systemic circuit. We discussed that. Protection, we talked about that just briefly when we talked about the leukocytes earlier. The cardiovascular system uses blood to carry those leukocytes, antibodies, and platelets throughout the body. The white blood cells, along with antibodies, fight pathogens and destroy foreign substances. Their ability to protect us from infection and disease is called immunity. We talked about the platelets or the thrombocytes activating the hemostasis or the blood clotting. And the next paragraph there goes into a little more in depth what actually is occurring with the process of the hemostasis. Make sure you read over that. Just for time's sake, I'm not going to read it. You're perfectly capable of doing that yourself. Then next up we have regulation as our third function. The cardiovascular system also helps maintain body temperature by constriction and dilation of the blood vessels. We talked about the negative feedback system of the temperature, the thermostats and stuff. When external temperature, muscle exertion, or fever create excessive heat, vasodilation of the blood vessels in the skin allows more warm blood to flow near the surface of the skin, where heat can dissipate. And then the opposite is also true. Vessels constrict, vasoconstriction in skin when the external environment is excessively cold, and in an effort to preserve body heat. And then we also have the shivering that kind of occurs in the muscular system that adds to preserving heat. Okay, the acidity or alkalinity of the substance is measured as pH. You have a neutral pH or pH balanced, indicates a substance that is neither acidic nor alkaline, and has a pH of 7. When the pH is below 7, the solution is considered to be acidic. If it's above, it's considered basic or alkaline. The interstitial fluids are kept at a pH of 7.4, which means the tissue fluids are slightly basic or slightly alkaline. The blood has hemoglobin and plasma proteins that act as buffers and chemicals that stabilize the pH levels. That's another way the cardiovascular system controls regulation. Okay, now we have the effects of massage on the cardiovascular system. So the effects of massage on the cardiovascular system are determined by where and how the strokes are applied. Specifically, if you have moderate pressure, the heart rate is going to slow down, the force of contractions are going to decrease, and the blood pressure is going to decrease. If you're doing percussion, that's your topotomic type strokes, your chopping, hacking, drumming type strokes, for lack of a better word. This initially is going to cause a reflexive effect, but then later on it's going to cause vasodilation and relaxation. The effects of the massage also is going to increase the circulation due to the mechanical effects. You're actually, to an extent, kind of pushing stuff along. And it's also going to enhance oxygen and nutrient delivery and waste removal. Make sure you read the box, all of your research boxes, but specifically massage and high blood pressure. Make sure you read over that. Again, do your assignment where you do your presentation or your visual aid listing the major components of the cardiovascular system, the functions of the cardiovascular system, as well as the effects of massage on the cardiovascular system. These are going to be great tools for you to use when you get ready for studying for your MBLEX. Okay, now we're going to flip over to page 243, and we're going to start talking about the pathology of the cardiovascular system. So, massage therapy mechanically increases circulation. It increases the delivery of oxygen to and the removal of waste from cells and tissues. Without oxygen, cells cannot thrive and they eventually die. Once the cell dies, it's destroyed and its remains are eliminated. The ends of the capillaries are the small structures that allow small molecules to pass through. Larger particles get caught in the very fine branches, essentially causing capillary congestion. Fragments of dead cells block the ends of the capillaries. They become less effective as transport membranes. Oxygen, other gases, and nutrients cannot get through the obstructed capillaries very easily. if at all. So this condition only compounds itself. The congested capillaries don't allow oxygen to pass. Lack of oxygen causes the cells to die. Those cells add to the congestion, and so on. It's kind of like the cycle we'd studied before with the pain spasm, pain spasm ischemia. It's kind of the same thing. Eventually, the situation causes pain and ischemia. Because massage mechanically enhances the circulatory system, massage can alleviate this ischemia by relaxing the muscles and creating more space between the muscle cells, which helps to restore the blood flow and provide better oxygen delivery and waste removal, which ultimately leads to better healing. So increased circulation is the key to healing. The healing mechanism begins when the tissues are damaged. And on page 244, you have a little description there of the actual healing mechanism. First up, I don't know why there's not a PowerPoint to this section. First up, you have the vasodilation. So vasodilation is automatically activated to flood the injured tissues with oxygenated blood, creating additional heat and redness. And as the area becomes enlarged or swollen with increased blood flow, inflammation occurs. The capillary walls then become thinner, allowing water to seep from plasma through the capillary walls and into the surrounding tissues, resulting in edema or swelling, which puts extra pressure on the nerves, which cause pain. Once the swelling occurs, blood flow slows down, and leukocytes, white blood cells responsible for the immune system, they pass through the capillaries to the injured tissues and clean up that area. They send out chemical signals to attract more of the leukocytes, and they kill the bacteria that may have injured the tissue there. They're setting up there from the dead cells. After inflammation subsides, other healing mechanisms take place. Sometimes tissues are regenerated or scar tissue is formed to replace tissue that cannot be regenerated. The speed of healing is very important. The speed of healing is always going to vary person to person. It varies due to age, their health, their nutrition levels, their emotional and environmental stressors. So stress factors plays a huge role in healing, and also their self-care. Generally, massage in the acute stage is 24 to 72 hours. Of tissue injury should be avoided while the tissue's healing process is beginning. So we never massage during the first 24 to 72 hours. That is considered to be the acute stage. In the subacute stage, so after the 24 to 72 hours and beyond, massage can increase tissue health via increased capillary transport of nutrition, may reduce emotional stress, and can be an effective element of self-care. Okay, next on 244 we have a bruise or contusion. This is simply a broken capillary on multiple capillaries in a localized area which form from which red blood cells seep out. Start to say which form red blood cells. No, a bruise does not form red blood cells. I'm mixing my words up. But localized area from which red blood cells seep out of the tissue, resulting from an injury such as a bump or a fall. Manifestations of a bruise includes the black or bluish colored skin in the initial stage, and we know that later on as it starts healing it kind of becomes even sometimes green or yellow. A contraindication, you never massage directly on top of a bruise. The etiology is typically it's caused from an injury, and there's no treatments. It kind of just self-dissipates. There is some techniques you can do with more training and stuff where you can work to dissipate the blood, and basically you're just doing really light massage over the top of the bruise, but again not in the acute stage, not when it's just happened and stuff. They can do that themselves. Okay, the next one we have is varicose veins. Varicose veins is manifested by bluish, ropey, and elevated veins in the legs. It is a local contraindication for deep specific massage techniques, and if they're bad enough, I don't even do lot techniques over varicose veins. You're at risk of sending a blood clot. There's no indications for massage. You definitely never do any deep. I say don't do massage over varicose veins unless it's like the weight of a nickel or less. Etiology is caused by damage to the internal venous valves, resulting in a retrograde or backup of blood flow and distension. So the valve's not really working properly, and it's letting the blood flow kind of seep back down through, and it's causing a buildup there in that tissue, under the vessel, sorry. Treatments can include support hose, elastic bandages, elevation of legs, injections of chemicals, or surgical removal. Sometimes they actually have to go in and surgically strip those veins. Again, read over your section there in the blue, the varicose veins in brief. It's pretty much what we just talked about, but read over it, make sure you have a good familiarity with it. And then next we have high blood pressure. High blood pressure can have no manifestations. Typically, it's only detected by blood pressure assessment. Sometimes people will have red face. Sometimes they will have, they'll talk about if it's excessively high, they'll talk about their head kind of burning or something. But typically, there's no real manifestation to high blood pressure. It's just they pick it up in the doctor's office when they check their blood pressure, which is one of the reasons why they always check your blood pressure when you go to the doctor's office. Contraindications, massage is systemically, so completely contraindicated in severe cases until the client's physician clears it. Most of your clients are going to be on some form of high blood pressure medication, unfortunately. It doesn't mean that none of them, if they're taking high blood pressure medicine, can get a massage. It just means that they need to check with their physician. The main thing is their medication needs to be controlling their high blood pressure. It's said that as long as the medication is controlling the high blood pressure, it's safe to do the massage. And it's actually indicated to do the massage if the blood pressure is controlled, because it reduces the physical stress, encourages the parasympathetic response within the body, and just helps to kind of relax them, which is going to help to bring the blood pressure down. The cause of high blood pressure varies. Treatments include medications or dietary changes. So what is high blood pressure? Well, this is a chart giving you some ideas of high blood pressure, or normal blood pressure all the way through high blood pressure. If you ever check a client's blood pressure, which I do occasionally, and I do keep a blood pressure cuff in my massage room if we ever need it. Your normal is anything less than 120 for systolic, or the upper number, and less than 80 for the lower. It's considered to be pre-hypertension if it's between 120 to 139 over 80 to 89. And then it's considered true high blood pressure if it's 140 to 159 over 90 to 99. And then stage 2 high blood pressure is above 160 over 100 or higher. And then if you ever check someone's blood pressure and they're at 180 or above, with a diastolic of 110 or above, you better be calling 911. That person is in severe danger. Okay, so that completes the cardiovascular system. Watch all your videos again if needed, and complete your quiz, and turn in your assignments. And we will pick up with the next section, lymphatic and immune system.